Hi, Chase. Can you hear me, Chase? Chase? Chase, can you hear me?
Yeah, I can hear you.
All right. With the problems we had last week, I just want to be sure, that's all. Okay, I think I threw that out. So are you still talking to me, Chase?
Yes, sir.
So you must have done okay on the quiz, on the test then.
Not really.
Huh, I didn't put the test results in here. Son of a gun. I can't believe I didn't do that. All right. Anyway, anything you got for me, Chase? Any questions about the test?
No, not really.
Okay. Anything else you got for me? This stuff should start to go a little easier. Should be a little more,
Was that just a hard
organized.
chapter?
I'm sorry.
Was that just a hard chapter?
What we just did?
Yeah.
Well, basically, I'm trying to pull in everything that you should have been taught in high school about chemistry. Okay.
Yeah. I didn't take chemistry in high school at all.
So again, that's what I'm trying to do. And it's there. If you noticed, there were a lot of topics that didn't gel one into the other.
Mm-hmm.
For at least the next 2 months, this should gel pretty easily. Okay.
Alrighty.
Because today what we're doing is we're talking about chemicals. Then the next chapter, we're going to be talking about something, chemical reactions. Then the next one is going to be about moles, and they all just flow one into the other.
Yeah.
Okay?
Mostly it's like I have a hard time trying to figure out like how different teachers do their tests and how to study for them. Now I know how like you do your tests and how I should study for them. So it was kind of messing me up with the studying.
This probably had more, definitely, this had more multiple choice true false questions in it than you will get in a future. Well, this next one would be pretty much like that as well. So I guess I'm lying to you. Okay. Hi, Armethea. Armethea? Guess she's not here, Chase. Armethea, you here? Armethea? Okay. Guys, if you don't have anything for me, I'm just here right now, just tap dancing until we get to start the thing, unless somebody has any questions. Armethea?
Hello.
Hi, Armethea.
Hi.
Any questions about anything?
No, I'm kind of confused.
What are you confused about?
I don't know. Every time I take a test, I don't know what happens. I can't remember what we learned or nothing in this class.
Well, you're gonna have to get over that. You're gonna find a coping mechanism.
No.
Right? And trying to find something. Ah, there we go. What's that, sir?
For the quizzes you assign, it's like, so you give the quiz and then we kind of go over that in class, right?
Yeah. Well, yes and no. It's like I gave a quiz today, but I have nothing to do for that. So basically, those should have been fairly general questions on nomenclature.
Mm-hmm.
I didn't think they were that hard. Did you think they were that hard?
They're kind of confusing because I had to do a little bit of research on them, but
Yeah, they were confusing.
They were confusing. Okay. Well, I'm not going to let you get away with that. All right.
Can an argument be made for 2 attempts on this quiz?
Nope.
Aw.
Oh,
I've already given the answers out. How can I give you another attempt when I've given you the answers?
Can't say I didn't try.
mhm.
Okay. Okay. Let's do it this way. Okay. Are you seeing the questions? Are you seeing edit quiz 6 up there?
Yeah.
Yeah.
Okay. Now we'll go down to the questions themselves. Okay. And it's just telling me I'm not going to change it. Don't worry about it.
Oh, and Professor, the discussion posts, are those graded?
Yep.
Okay.
Oh man, for real?
Oh man, for real, yes. That's if you noticed at the participation points.
Oh man, for real.
Yeah, that burns you. That burns you good time. So trust me, start doing it, okay? For a couple reasons, guys. You guys, this class has done a fairly good job. If you go to the forum, you go to the student forum, you will see that people are literally having legitimate discussions about what we're discussing in class, what you understand and don't understand. On the homeworks, there are people that are solving them, okay? And they're having discussions about what you don't understand. Guys, avail yourself of this.
Wow.
Okay, now I've got the questions before you guys. In an ionic compound, the portion of the molecule that is positive is called the cation.
Sure.
I actually did talk about this last couple of lectures ago.
That one's true.
Yeah, that was true.
All right. Cations are found on the left side of the periodic table.
That's the one I missed. I don't know.
Would that be true because they classify as like alkali metals and
Okay, what makes a cation? Cations are the things that are positive. The things I told you last week, that the things on the left side of the periodic table like to give up their electrons, so they're going to be positive. So the left side are going to be positive, right side are going to be negative. Okay?
Mhm.
The compound magnesium chloride has a polyatomic ion. Again, you got to look through, guys. If you haven't at least scanned through the PowerPoints, if you haven't at least scanned through the PowerPoints before you do these quizzes, you don't have a chance. You really don't have a chance at doing them. Okay, I want you to at least look through the PowerPoints.
I only missed the last ones at the bottom. I knew most of them, but
Okay, that's great, Armithia.
they were confusing.
Okay. Last couple questions. Okay, I'll go back down there. Number 10 was a trick question. There is no prefix.
Yeah, I missed that.
That is, again, these are things that were in the PowerPoints. One up above it.
Yeah.
True, false question. Okay. What you have to know, all ionic compounds are neutral. They have no charge. Okay.
Mm-hmm.
So if you have calcium has a +2 charge. Chlorine has a -1 charge. So if you have 2 calciums for every chlorine, you have two pluses, that makes 4 pluses, correct?
Mm-hmm.
And you only have 1 minus. Is that balanced?
No.
So is this a true statement?
Oh. Wow. I didn't
So,
see that.
it's amazing when it gets
It's kind of
explained.
tricky. It's tricky when you're taking a class.
It's tricky, but that's the first thing I'm going to get to today. Okay, that will be the first thing that I get to today. All acids begin with what element?
Hydrogen.
What'd you say?
Hydrogen.
Hydrogen. Absolutely. Covalent compounds do not use prefixes in their name.
False.
Very good. Even though ionic compounds have charges within them, the overall charge of the entire ionic compound is 0.
True.
You know these answers, Armethea.
I just missed the last two
Okay, well,
because they confused me.
well, again, that's sometimes you take quizzes to find out what you don't know and what you should be paying extra attention to. Does that make sense?
Yeah, because some things confuse me. I know most of it is like when I take the test, I'll be like, what? And then I'll miss it.
All right, got any other questions about these? Again, be aware that Thursday's quiz, I'm going to ask you very, very specific questions on what I go over today. Those are going to be the hard questions. You also have some easier questions on what I'm going to be going over on Thursday. How's it going, Faith?
Yeah, it's going.
So are you still talking to me? I'm trying to figure out who's talking to me and who's not.
Oh.
From the test. You guys didn't do bad. You guys did okay. For the most part, you did okay. It was a strange thing. This class, I had many more A's than my HCC class, but my HCC class, I didn't have anybody that bombed it. So ultimately, my HCC class ended up with a higher average than you guys did. So we'll have to wait and see what happens with that. Any other questions? I got to see if somebody is. Oh, that's me. Okay.
I just had questions about sig figs. I still don't understand them and how many we're supposed to in the decimals.
Faith, I think I graded your thing today. Are you in tonight's lab?
Yeah.
Okay.
I got a C on it, and most of it was because of the sig figs or improper calculations.
Okay. Actually, it could do, that's going to do you all some good. Let's let me do. Okay. You seen a slideshow?
Yep.
Okay. Are you okay with identifying?
I'm okay with identifying how many sig figs there are. I think the one issue I just have is measurements with sig figs, like especially for the grams part of the lab.
The last one? Are you talking about measurement readings, Faith? Or are you talking about sig
readings with sig figs?
Okay. All right. What you have to do, let me see if I can, I'm going to get rid of this. I thought you said sig figs, so that's why I brought this up.
Oh, sorry.
No. I'm trying to find what I need for this. All right. Okay, we're going to try this one. Okay. Okay. And to go down here. Okay, here we go. All right. All right, Faith. Now, anytime you have any measuring device, you're going to have two of the lines that are going to be marked. Does that make sense to you? Have to figure out what the unmarked lines are. So you got to go by first what the marked lines are. Okay, in this particular case, this line is marked 20, this one is marked 30. So this means I have 10 units between here and here. Does that make sense to you, Faith?
Yes.
Okay. Now, you could do it one of two ways. The numeric way to do that is to figure out how many spaces. If I count the spaces, I would have 10 spaces. So I would know, I would take the 30 minus 20, divide that by 10. I now know what the smallest line is. Does that make sense, Faith?
Can you repeat that? I'm sorry.
Okay, I know that the number of units between the 20 and 30, there are 10 units between 20 and 30, right? If there are 10 spaces between them, then I divide those 10 units by the 10 spaces, then each of my small lines is worth 1.
Yeah.
Okay? If you don't like that, if you don't like the number system, try something else. Try saying, okay, well, I think that each line is worth 5 milliliters, okay? So if each line is worth 5, then I go to the first line, 25, 30. Oops, I'm not there yet. So I'm not there. I'm already there. I guess somebody's trying to sell me something. So I'm already at 30, but I'm only at the second line. So can each line be worth 5 milliliters, say?
No.
All right, try something. Give me another number.
2.
Okay. First line 22, second 24, 26, 28. Oops, I'm already at 30. So can each line be worth 2?
No.
Try something else.
3.
Faith,
1.
Faith,
1.
if two got me there before 30, don't you think 3 is going to get me there even faster?
Maybe.
23, 26, 29, maybe. Let's try 1, okay? 21, 22, 23, 24, 25, 26, 27, 28, 29. Oh, lo and behold, each line is worth 1 milliliter. Does that make sense to you, Faith?
Yeah.
All right. Now, that is what we know. We now have to estimate. Okay? So if I get a line that is I'm trying to find out where okay. I get the bottom of my meniscus is right there. Okay? Faith?
Yeah.
Okay. How many lines up from 2023 is, let's go back to the original one. Okay. How many lines up from 20 is that?
7.
So it's at least 27 because each one of the lines is worth 1, correct? So it's at least 27. Is it a little bit above 27?
Yeah.
Is it 228?
Can you repeat that?
Okay, it's a little bit above 27. Have I reached 28 yet?
No.
So I'm somewhere between 27 and 28,
Mhm.
right?
Yep.
So how far up do you think that is?
27.4.
But you see what you did there?
Yeah.
You knew it was good to the 27. Okay, so you estimated one more digit to the right.
Okay.
Does that make sense too?
Yeah.
All right, now let's go down to the next one. Okay, you notice the numbers are going down here. By the way, ladies and gentlemen, if anybody has something that they want to talk about, just yell out. I'm helping Faith here learn about measurement readings. All right. Okay, Faith. You notice the numbers are going down, right?
Mm-hmm.
That means you got to read them from the top down. Okay. And let's say we have something right here. Okay. Now we got to figure out what each one of these lines. If from here to here, from 22 to 23 is 1 unit, then what do you think each one of these lines is worth, Faith?
0.1.
0.1. So if you're going to estimate, what are you going to have to estimate to?
The 0.1? No, 0.01.
0.01. You're getting it now, Faith. You're getting it. So if you're going to get what this one is, how many lines do you know? How many lines down is it?
6.
22.6. Now give me your estimate.
22.67.
That's all you have to do. Okay.
So you just add in another significant figure.
If when you do this math out, if you come up with a multiple of 1, like 1 milliliter, 10 milliliters, 100 milliliters, yes, you can do it that way. If it's something other than 1, then you can't do that extra estimate to the right. What has to happen is you're going to be estimating the line that you see. Let me see if I can give an example of that. All right. Now, if I do this and I count the lines, I skip, each line is worth 0.05, then every other line's 1. So 21, 22, 23, 24, 25. So each line is worth 0.5. Okay, Faith?
Yep.
I cannot take it out any further than the 0.5. You've gone beyond the ability to reasonably estimate. So that is the furthest. The 0.5, the one place past the decimal, is the last place that I can record a number for.
Okay.
All right. So if I get something that is, say, right there, okay, then I know we got to understand what's happening here. This is 20.5, second line up is 21. It's 21, but not quite to 21.5. Okay.
Mm-hmm.
So you can call that something like 21.6 or 21.7. Make sense?
Wait, 21.6. Oh, wait. No, I remember now. Okay. Yeah.
Okay. Now, unfortunately, Faith, I'm going to have to get starting with class because we usually go over anyway. All right.
Yeah, that's fine. But this
Okay.
helped.
Faith, when are you in lab? Tonight?
Yes, tonight.
Well, then we'll possibly work on this a little bit more later tonight. Okay.
Okay, thank you.
Okay, ladies and gentlemen, who's not speaking to me?
Me?
Who's me?
Victoria.
Victoria, why aren't you speaking to me?
Well, I have a really bad cold
Okay.
and my camera isn't on because I don't think anyone needs to see how disgusting I look. So
Oh,
I'm
come on.
here
I love
to,
disgusting.
oh no, this is for the best. I promise you. But I'm here. So yeah.
All right, good enough. I got 20 other, I got actually 19 others here. Anybody have any questions about the test or the extra credit? Does everybody
Wait,
realize that extra credit
question.
was offered? Terry,
Alright,
yes. Terry,
So the extra credit, can you hear me?
is that Terry?
Yes, sir.
Yes, I am hearing you.
Alright, so the extra credit, was that optional or mandatory with the discussion post?
Uh, I'm not understanding what you're saying, Terry. Extra credit is always optional.
Alright, so that was for the, excuse me, the discussion post, right?
Yeah, what I did was I believe I have that listed as a module in the course, right? So guys,
Right.
tell me if I'm wrong. I have it listed as a module, and within that there is a discussion forum.
Alright, cool. I was just a little concerned because my grade went down because I didn't know about the extra credit.
The
Or
grade went
rather, I
down.
guess I didn't, yeah, my grade went down to like a 72 after you put in the grade for the extra credit, and I just
No, I
didn't.
haven't put in the grade for the extra credit. The extra credit can only increase your grade.
So it wasn't that participation grade that was in there?
Oh, that's yeah. Good. Glad somebody brought that up. Ladies and gentlemen, I am very proud of most of you. Most of you have been doing this like you're supposed to. You guys just started right on and you went right into the student forum. You started asking questions. You got some of your classmates to work with you. That is what you're supposed to be doing. Okay. There are, if you don't like doing it, some people don't like to get into a group conversation. That's fine. I have 3 homework questions that you can get involved in. But the point is, you need to give me 3 things. The way your participation grade was based on the last 2 weeks, you should have given me 6 responses. If you got something like a 10, that meant that you gave me 4 responses. If you got something like a 13 in participation, that means you gave me 5 responses. All right. You gave
So
me
Professor,
something.
every week there are 3 discussion posts due? Oh, see, I thought there was only 3 a week. I happen to answer 4. So, all right, thank you.
All right. I mean, somebody, if I remember correctly, actually I have that. Somebody did 8 posts. Neela did 8 posts. Rosina did 10. Okay. Over and above, guys. But you need to do at least 3 a week. And really and truly, I'm trying to do this for you so that you will help each other. Okay.
Professor, I have another question. So because you sent the email saying that the extra credit for the test was available, is it the correct one on my courses this time? Because the next email you sent said it was the wrong one. So is it the updated one?
Okay. Let me go in there. Okay.
Okay. I
Let's-
just want to make sure.
Are you seeing the introductory chemistry? What are you seeing on the screen right now?
I'm seeing your PowerPoint, what you're
Okay.
sharing right now.
All right. Uh,
I just want to make sure it's the right.
I'm trying to take you there.
Okay.
Okay. Course content. Okay, all the way down to the left. Extra credit. There it is, right there.
Okay, I just want to make sure it was like the right one, because I think you sent out an email saying that it was the wrong one or something like that. So I want to make sure that it was updated.
To be honest with you, I have sent out buku number of emails. I have
I
no
think
idea what
everything-
I've said where.
I think on
The
the,
email was about the due date.
yeah, you said the due date was February 9th and then you corrected it that it was the February 11th.
Okay,
Okay,
that seemed fair to me. Okay,
cool. Just want to make sure.
okay. Good enough. Okay. Are we good? Any other questions, ladies and gentlemen? Okay, you're gonna watch me work out. I used to work out with a whole bunch of things, but I got tiny little weights now. I'm an old man, so I'm working out, right? I'm doing good. Okay. What happens, ladies and gentlemen, if I have a 2-pound weight in my left hand and I have a 1-pound weight in my right hand? And I keep on doing this. Eventually, after 20 million years, this arm's going to get twice as big as this arm, right?
Right.
So tell me, how do I make sure that doesn't happen? I have a 2-pound weight in my left hand. I have a 1-pound weight in my right. I can only put 2-pound weights in my left hand. I can only put 1-pound weights in my right. How do I fix that?
You'd have to work out your right side
You could-
twice.
Yeah, or you could work out the left less.
Oh, yeah. Or the left's less.
I could do that. Or
Or
what
pick up a
else could I
second.
do?
Get another 1-pound weight.
Get another 1-pound weight so I can do this, right? So if I have 2 pounds in my left hand that is donated by 1 weight, I have 2 1-pound weights in my right. Make sense? Does this make sense? Okay,
Yeah.
let's figure something else out. What happens if I'm really, really getting big, okay? And I'm going all the way to a 3-pound weight. So if I have a 3-pound weight in my, we're gonna go this way. We're gonna work out my right hand this time. I have a 3-pound weight in my left hand. I have 1-pound weights in my left. How do I get this equated?
Get 3 1-pound weights.
3 1-pound weights. So, whoop, that's a no. There we go. They're
How many
pink.
weights does he have?
Don't you just love the fact that they make the 1-pound weights pink? So I have 3 1-pound weights in my left, 1 3-pound weight in my right. And so I can keep on working out like this, right, guys? And I'm going to be working out, I'm going to be symmetrical, right? Riddle me this. If I have a 3-pound weight in my left hand and I have a 2-pound weight in my right, how do I make them equal?
Put 2 1-pound weights in your left.
No. I can only put 3-pound weights in my left. I can only put 2-pound weights in my right.
Get 3 2-pound weights and 2 3-pound weights.
Does that seem reasonable to you guys? Oh, you're making me work now, guys. Jeez. Okay. Does that seem reasonable? I have 2 3-pound weights in my left hand and 3 2-pound weights in my right. I have equal weight in that. Am I saying something that makes totally no sense to you at all?
It makes sense.
Good. We're going to go on from there, all right? Because right now, what we're going to do is we have to learn how to balance our chemicals. And that's not what I want. Stop share. Share screen. No. Balancing compounds. There we go. All right, ladies and gentlemen. So what we got to figure out is how we are going to balance things. And so what we're going to talk about in this PowerPoint is balancing ionic compounds. And we're going to talk a little bit about empirical versus molecular formulas. All right. Okay. Remember when we were talking about valence electrons, we talked about the two types of bonds. The one type was ionic and the second type was covalent. Covalent compounds do not have a charge. No charge in them. All the electrons are shared between the two atoms. Electrons are shared. They're whizzing around. They are shared. One atom doesn't control the electrons, so we are basically balanced. So in order for us to tell how many atoms are in the compound, we have to be either given the name or the formula. Have to. You have to have the name or the formula. If you don't have one or the other, you can't tell me what something is. Now, we can work around that with ionic. Ionic compounds do have a charge. We know two things with ionic compounds. One is they have charges, and the second thing is ionic compounds overall have a zero charge. Therefore, we have to balance the molecules so that they do end up having a zero charge. So if we have ions, then the ions have to be multiplied by their subscripts. Then once we multiply their subscripts by the amount of charge on each, we can tell how much charge is on each one of those ions. So I'm going to repeat this. Several times over the next couple weeks. Compounds are balanced with subscripts. Remember when we were counting the atoms, the subscripts were the little numbers to the right and below the elemental symbol. Compounds are balanced with subscripts. Chemical equations are balanced with coefficients. The coefficients are the big numbers to the left of the overall chemical formula. Compounds are balanced with subscripts. All right. Now, in order to figure out what the charges are, we have to realize a couple things. There are two types of cations. Cations are positive ions. If we have a type 1, that's only one possible charge is on that ion. Type 2, that element can have more than one charge. Okay? So, there are three categories of type 1. The group 1, the alkali metals. Remember way back when I had you put a 1+ on the top of where hydrogen was? Do you remember that? All of the elements in that column have one valence electron. They are always, each and every time, going to have a +1 charge. So if we're looking at the periodic table, the column that is the furthest to the left, that column will always have a +1 charge. We have a second group called the alkali earth. The alkali earth are the column just next to the alkalis. They have 2 valence electrons. They will always have a +2 charge. They are headed They're headed by beryllium. Beryllium is the first element. So if you put a +2 above beryllium, all the elements that are below beryllium also have a +2 charge. There are 4 others you have to memorize. It's the only way you know them. Aluminum always has a +3 charge. Zinc will always have a +2 charge. Silver, a +1, and cadmium, a +2. Each and every time that you see these elements in a chemical compound, that is what the charge has to be. Okay?
Did you say cadmium was +2?
+2.
Thank you.
Okay? Now, there's only one polyatomic cation, only one. A polyatomic ion is simply an ion that's made up of more than one element. In this case, NH4 will have a 1+ charge, and it will always be a 1+ charge, and it is the only polyatomic cation. Okay? Now, if type 1s are the first column, second column, aluminum, cadmium, zinc, silver, and ammonia, what do you think type 2 cations are?
All the other ones?
Everything else. Okay? So if it is not in any of these categories, plus this one, it is a type 2. Remember, type 2 cations, you don't know what the charge is, but you got to know it. So how do we know it? We use the anion. Okay? Don't worry, that doesn't mean anything. In order to find out the positive charge on the cation, we have to use the anion, because we're always going to know the number of the anion, and we're always going to know the charge on the anion. Charges are always defined for anions, and there are 2 types of those. There are monoatomic and polyatomic. Terry, what do you think a monoatomic? How
Only
many-
one atom has the charge.
Not on one type of atom. Okay? Just
Okay.
think of it in that way, one type of atom. Because if you have something like MgCl2, there are 2 chlorines, but that's still a monoatomic because there's only one type, chlorine. Does that make sense, Terry?
So yeah, chlorine would be the only one that had the charge, right?
Right. Well, actually, chlorine has a charge and magnesium has a charge. Okay? Terry, you can't have negative without positive, right?
Oh, so you have the balance, right?
You have to balance them. Okay? So when we're dealing with a monoatomic anion, that just means that it's composed of one type of element. Like, for example, MgCl2. There are 2 chlorines, but they are one type of element.
Gotcha.
A polyatomic, on the other hand, has at least 2 different kinds of elements in it. SO4, sulfate, has a sulfur and oxygen in it, has a sulfur and 4 oxygens in it. So therefore, it's called a polyatomic ion. But we always know what the charges are on either one of them. So if we are dealing with a monoatomic anion, if we are dealing with not the last one, not the furthest one to the right, because those guys have 8 electrons. Those guys are not going to react. The column just to the left of the noble gases, those are called the halides. If we start with fluorine and go all the way down, all of those have a -1 charge. We go one column over, the family starting with oxygen. All those straight down have a 2- charge. Go one more to the left, we're in the nitrogen family. All those going down have a 3- charge, always, no exceptions. Well, for your purposes, no exceptions. Okay? Now, unfortunately, guys, you got to memorize. Or, because Mr. Popovich is a kind and benevolent teacher, he allows you to have cheat sheets. So you're not going to have to memorize. I'm more interested in you being able to put the molecules together than you memorizing these things. All of these 10, you should know, you should be familiar with. If I have a polyatomic, again, acetate has 3 elements in it: carbon, hydrogen, and oxygen. So if I have an acetate, the formula is C2H3O2. It always has a 1- charge. If I have an OH, that's a hydroxide, it has a 1- charge. NO3, NO2, they each have 1- charges. And you got to understand, if I have nitrate, I have to keep everything together like a family. I have to have 1 nitrogen and 3 oxygens, or else it's not nitrate. I have to keep them together. Similarly, if I have chlorate, ClO3, I have to have 1 chlorine and 3 oxygens in order for that ion to be a chlorate. All the formulas you see here with the names, they're all a -1. -2, the list is a little bit less. Carbonate, CO3, sulfate, SO4, sulfite, SO3, chromate, CrO4, and dichromate, Cr2O7. All of these polyatomic ions, again, they're called polyatomics because I have at least 2 different elements that compose them. All of these 5 have a 2- charge on them. I have a 3-, phosphate, phosphite, PO4, PO3. These have a -3 charge. Now, guys, I want you to open if you have your survivor guide, I want you to have it opened to module 5, formulas and compounds. If we go into module 5, page 7, you're going to have a list of the polyatomic ions. I provided some here. The list that's on page 7 is a little more extensive. I would like you to open your books there and leave it out for the next couple of days. All right. Now, remember what I said. All ionic compounds are neutral. So we have to write formulas. Now, when we write formulas, the total positive charge has to equal the total negative charge. So barium is in the alkali earths. I know that's a type 1 cation, and I know it has a +2 charge. C2H3O2 is acetate. And if I look on my chart on page 7, or if I look in my little chart, I'm going to see that acetate C2H3O2 has a 1 minus charge. Now, remember the weights. Remember when I had a 2-pound weight in my left hand and my right hand weight, I could only have 1 pound weights in it. How many 1 pound weights did I need to equal the 2-pound weight?
2.
Makes sense? 2, okay? So if we develop the analogy, if I have 1 2+ charge for my cation barium and my acetates have a 1 minus charge. So my barium is a 2+, my acetate is a 1 minus. How many acetates am I going to need to equal the charge so the molecule is neutral?
2.
2. So what I have to do, remember, we're a family. These anions are families, okay? Anybody have a little brother? Come on, somebody's got it. Who's I do?
Aya.
Aya. Is your little brother obnoxious?
Very.
I can say that because I was a little brother. Okay? Now, Aya, if your family is going to Atlanta, right?
Okay.
You have a weekend plan. You have some things you want to do up there. You want to see the botanical gardens up there. You want to go out and see the Centennial Park. Whatever it is. You want to go to the Coke factory. Whatever, okay? Now, Aya, are you gonna dare leave your little brother behind? Remember this, Aya. If he's behind, he's going into your room. He's finding your things and he's going through them. Are you going to leave him behind?
No.
Not a chance in the world. Okay? So, ladies and gentlemen, when we are writing formulas, we have to include all of the elements that make up that polyatomic. So if I have acetate, if I have C2H3O2, that is acetate, I have to include all of them within the parentheses. That's my whole acetate family. So I'm going to put parentheses around it, and then I'm going to say I need 2 of them. On the other hand, Jennifer.
Yes.
Okay, sodium. Do you know what the charge on sodium is? Do you have your periodic table out?
I know, but I memorized it. It's +1, right?
+1, okay. So sodium is a +1. Acetate is a -1. Are they balanced already?
Yes.
You got 1 + 1, 1, 1 minus. They're balanced. We don't have to mess with subscripts then.
Mm-mm.
Okay, so ultimately, the amount of positive charge must equal the amount of the negative charge. So basically, you got to figure out what the quantity of charge on the cation is and determine the quantity of charge on the anion and apply the appropriate subscripts. If the charges match, you're done. Nothing more to do. If you have barium sulfate, the charge on barium is a +2. The charge on the sulfide is a -2. Those match. You don't have to apply any subscripts. Subscripts of 1 are understood. We get aluminum, that's a +3. We have nitrogen, that's a -3. Again, they match. We don't have to worry about applying any subscripts. It's when they don't match that we got to worry. Again, if they don't match, you got to think about how I balance the weights there. We're going to figure out what the common denominator is, and we're going to multiply the number of ions by whatever number it needs to be multiplied by to get to that common denominator. All right, we have aluminum and chlorine. Mila. Aluminum is a +3. Chlorine is a -1.
Okay.
Okay? If I just put AlCl, that's not balanced, is it?
No.
So how many chlorines do I need to add to that compound to make sure it's balanced? How many chlorines do I need to balance one aluminum?
3.
3. So what I'm doing is I'm multiplying the 3+ for aluminum by 1, which is the subscript for aluminum. I'm multiplying the chlorine by 3 because I need 3 of them to equal the +3. So overall, my subscript for the chlorine is going to be 3. My subscript for aluminum is going to be 1. My formula is AlCl3. Are we good with this?
Yes.
Mhm.
Can I get another example? Because you broke that one down really well.
Okay.
Yeah, I'd like one too, sir.
All right. We have magnesium and phosphorus. Terry or Hunter, do either one of you have a periodic table?
Yes, I have it in front of me.
Magnesium, what's the charge?
That's +2.
Phosphorus?
That's going to be -3.
Okay. So what is the common denominator between 2 and 3?
1.
1?
6.
Or
6.
6.
Hunter. 6.
You said
The common factor, least common factor. Okay.
Yeah.
It's going to be 6. So if your common factor is 6 and your charge on magnesium is 2, how many magnesiums are you going to need? How many times, what are you going to multiply 2 by to get to 6?
3.
So that's going to be the subscript for my magnesium.
Okay.
What do you have to multiply 3 by to get 6?
2.
That's the subscript for my phosphorus. So overall, my compound is going to be Mg subscript 3, phosphorus 2. Okay.
All right. Yeah, that makes sense.
Is everybody with me? Do I have you with me here?
Yes.
Barium bromide. Okay. Hayden. I like the hair, Hayden.
Thank you.
Okay. Barium bromide. I lost my screen. Nope, that's not it. Did I lose the screen for you too, guys? Are you still seeing the screen, Hayden?
Still
You
see
Yeah.
it. Yeah.
All right. Hayden.
Yep.
Okay, barium is a +2. Bromine is a -1. Do you need more bariums or do you need more bromides?
We need more bromides.
How many more of them do you need?
1.
Yeah, just one.
All right, guys, think of this as multiplication. Okay? We're not going to add. We can't. Have you ever seen a chemical formula where it says BA/BR 1 + 1? Doesn't do that. We're going to be multiplying. What do I have to multiply the -1 by to equal 2?
2.
-2.
2.
2. Okay, so this means because it's 2, this is implying that my barium, the barium's fine. It has a subscript of 1, so I leave it alone. My bromine, I need to have 2, so it's going to look like that. Hayden, you good with this?
Wouldn't it be a negative 2? Because
Well, no. Okay. Because let's see what's happening here, okay? Remember, all of these have to be equal. We have to end up with zero charge, right, Hayden?
Yeah.
So if I multiply 2 plus times 1, to that I add 1 minus times 2, right? This equals 2 plus a 2 minus.
Oh, and that would be 0.
Exactly. That's why we don't say a negative, right?
Where does that like negative is just applying to the charge, not the number, right?
Correct.
So
Okay.
basically, we're not following that multiplication rule of if it's a negative, then the number will be
Well, the negative's not even applying to the number, it's just applying
right to the charge, right?
So you wouldn't even like really look at that in correlation to the number that's there.
But
Got
keep in mind, we're trying to get the overall charge on the molecule equal to 0.
Yeah.
All right. If I have a polyatomic, remember, is one that has different elements that comprise the entire ion. You have to understand that that ion stands by itself. Okay? So if I have Al and NO3, this is just the same thing as when we had Al and Cl. The Al was a +3, the NO3 was a -1. So how many NO3s do I have? Do I have to balance the charge?
Wouldn't it be 3?
3? Absolutely. 3 times a -1 equals -3. 1 times a +3 equals a +3. The overall +3 plus a -3 equals 0. Now, the difference is, because this is a polyatomic, I got to keep everything together with parentheses. So when I write the compound out, it's Al parentheses NO3 taken 3 times.
And that's because that 3 on the outside is only applying to the NO.
NO3.
The NO3, yeah.
NO3. Keep it, Mila, make sure you keep that in mind, because the 3.
Yeah, I'm saying that like the parentheses are around that because that 3 on the outside is only applying to that inside.
Correct.
Okay.
Correct.
Okay.
All right. I have Fe and PO4. Marie, you there, Marie? Marie.
Yes, I'm here.
Okay. All right. I have to tell you the Fe is a type 2 cation. So I have to tell you what the charge on that is. The charge on Fe is a 2 plus. The charge on the PO4 is 3 minus. Okay?
Okay.
So how many Fe's am I going to need?
4.
4 times 2 plus would give me an 8 plus.
Oh, okay, yes, you multiply 8 by 2, 4 by 2, 8.
Okay. But that's, can I divide 3 minuses into 8 pluses and get a whole number? No. Okay. Marie, you're seeing, what you're doing is you're seeing this 4 here and thinking that that is multiplying this whole anion. Don't do that. What you have to get your mindset into is that PO4 is the entire thing. Okay, Marie?
Okay.
In order to have a phosphate, you have to have one phosphorus atom, and 4 oxygens. If you don't have that, you don't have a phosphate anion. And that whole thing, the conglomeration of that P and those 4 O's makes a -3 charge. Okay?
Okay.
Marie, you with me so far?
Yes, I'm
All right, Marie. So iron is a +2. Phosphate is a -3. What is the lowest common multiple between 2 and 3?
6.
6. Okay.
Mhm.
So what do you have to multiply 2 plus by to get 6 plus?
3.
3. So that means that my subscript for my Fe is going to be 3.
3.
All right.
Mhm.
Now, again, you said that the least common multiple was 6. What
Yes.
do you have to multiply 3 minus by to get 6?
2.
So my PO4, my whole phosphate ion, has got to be multiplied by 2. So the 3 is my subscript for iron. And my 2, remember, this is a polyatomic, so I have to bracket the entire polyatomic with parentheses and put a 2 down there.
2. Okay.
Is this making sense, Marie?
Yes.
All right. Now, basically up to this point, we've been working with type 1 cations. We know what the charge is, okay? We absolutely know what the charge is. With a type 1. Type 2, we don't know what the charge is. So we're going to have to use the anion to determine what the charge is. All right. In order to do this, we have to have one of 2 things when we are doing this. We either have to have the formula or we have to have the name. Have to. If we don't have the correct formula, we cannot determine what the charge is. If we don't have the name, we can't determine what the exact formula is. You have to have one or the other. So we are going to use the anion to determine what the charge on the cation is. I have cobalt sulfate. Okay. This is, I have to tell you, remember I said I have to give you the formula? This is a balanced chemical. So the charge on the sulfate is a -2. There's no parentheses, no subscript. Therefore, there's one of them. So my total negative charge of this compound is a -2. Now, remember I said that the compounds have to have a total of no charge. So if the total negative charge is -2, what does the total positive charge have to be equal to?
+2.
2.
+2. Now, we have to understand, this is our formula. We now know that the total positive charge is +2. We look down. We look at the subscripts for the cobalt. What's the subscript on the cobalt? Is there
1.
any subscript?
1.
Understood to be 1, right? So that whole +2 charge is distributed amongst one cobalt atom. So the charge on that one cobalt is +2 divided by 1. That charge on that cobalt is a +2. Are you understanding how that's working now? Are we good there?
Yes.
If I have Fe2 SO4 parentheses taken 3 times. I know that the negative charge on each SO4 is -2. How many of them do I have? Rosina? Each
I'm sorry,
SO
could you repeat the question, Professor?
Each SO4 is a -2.
Mhm.
Okay? How many of them do I have? What's the subscript for SO4?
3.
So if there are 3 of them and each one is a -2 charge, what is the total negative charge on the sulfate?
-6.
-6. So Rosina, that has to be balanced by how much positive charge?
We only have 2 with
No,
iron.
no, 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 no.
Oh, okay.
Right? The -6, in order to have a neutral molecule, the -6 has to be balanced with
A
how many?
positive 6.
+6. Okay? Now, what is the subscript for the iron?
2.
So if the total charge is a +6 and there are 2 iron ions, that charge is going to be equally distributed between the 2. So I'm going to divide the +6 by 2. Each of those irons is a +3. Does that make sense to you?
Yes.
All right.
Also, Professor, I don't know if the observation that I'm making, it can be generalized and can be applied to all of these compounds, is that when you said with barium and bromine, barium had a +2 and bromine had a 1-. And when you combine them, it's almost like cross multiplying and it becomes BaBr2. And
I'm
it
gonna
looks
get
like
to
it's
that.
the same thing.
I'm going to get to that, Rosina. Trust me. All right. As a
Okay.
matter of fact, Rosina, my next slide. Now,
Oh,
okay, my next slide, ladies and gentlemen. If you know the charges, you can do a cross. It's almost like cross multiplying, just like Rosina said. Basically, if I know my subscript for my copper is a 3 and my subscript for my nitrogen is a 1, then simply take the subscript from the nitrogen, move it above the copper, and that means that my copper is going to be a +1 charge. If my subscript for my copper is a 3, I'm going to move it over, and that's going to mean that my nitrogen has a -3 charge. Does that make sense to you? This will work 95% of the time.
What's the other 5%? Because this makes a lot of sense, the crossing concept.
Hunter, it will work 95% of the time. Where it
Hold on,
doesn't
would
work,
nitrogen have a -1 or -3 charge?
what's that? Go ahead.
Would the nitrogen have a -1 or a -3 charge?
-3, because you're moving the subscript from the copper over above the nitrogen. It's crossing. It's crossing. Whatever the subscript for the cation is going to be the charge of the anion. Whatever the subscript of the anion is, that's going to be the charge of the cation. Okay? Now, Hunter, you ask an interesting point. Okay. Do you see this, Hunter? If I have Au2 SO4 in parentheses 3, that means that the subscript from the SO4 is going to be the charge on the cation, a +3. The subscript on the gold, the cation, is going to be the charge of the SO4. Wow, Mr. Popovich, this seems so much simpler than that bullshit you were talking about.
I didn't want to say it. But yeah, no, this is extremely useful. So the 5% you're saying, take the subscript from outside if it looks like that. Okay.
All right. You can't use this all the time. You have to understand when it can't be used. If you have PbO2, it would seem that the If we cross these things over, Pb would have a +2 charge and oxygen would have a 1- charge, correct, guys? Does that make sense to you?
Yes.
Yeah.
All right. Oxygen will never, never, ever, ever, never, ever, ever be a -1 unless it's bonded to itself. It won't happen. It can't happen unless it's bonded to itself, like in something like hydrogen peroxide. Oxygen will never be a -1. So oxygen always is going to be a -2. So if oxygen is a -2, 2 times a -2 is a -4. That balances with the positive charge being a +4. That's distributed amongst one lead, so that the lead is going to be a +4. The oxygen is going to be a -2.
Is it because oxygen isn't stable enough by itself?
No, it's because oxygen is very electronegative.
Okay.
It's the second most electronegative element on the table. Okay? The only time it's not going to want to grab 2 electrons for itself is when it's bonded to itself or when it's bonded to fluorine. Those are the only 2 exceptions to oxygen not being a -2. Again, if we have something like SnO2, we know the charge on the oxygen. That's a -2. So 2 times a -2, we have a -4. This has to be balanced with a +4 for the tin. It's distributed amongst one atom. So the charge on the tin must be a +4. Questions? Questions on this? All right. I'm going to get into molecular and empirical formulas real quick. I'm going to hit on this real quick. It's basically a very simple concept. The molecular chemical formula includes all of the elements that comprise that atom or that compound. The molecular formula includes all of the atoms that make up the actual compound. The empirical formula is the lowest whole number ratio between the atoms in a molecule. So, molecular formula has all of the atoms. Empirical formula, we've taken all those atoms and divided by a common denominator, and we have lowered that down to its lowest whole number ratio. It's going to make sense. It's a simple concept. It's going to make sense if you see them side by side. If I have hydrogen peroxide, the molecular formula, hydrogen peroxide consists of 2 hydrogen atoms, 2 oxygen atoms. Okay? But if I have that formula down, H2O2, I can divide all of those subscripts by one number, 2. And this gives me the lowest whole number ratio between the H's and the O. So the molecular formula for hydrogen peroxide is H2O2. The empirical formula is HO. All right. Let's see who else is out there. Participants. Christina.
Yes, sir.
Okay. If I tell you that the molecular formula for benzene is C6H6, is there one common number you can divide all the subscripts by?
6.
Okay. So if you do divide it by 6, what is going to be your empirical formula?
Just CH, right?
Guys, that's as simple as it is, okay? Let me see who else I can get and bother. Aaron?
Yeah.
Okay, Aaron. The molecular formula for glucose is C6H12O6. Is there one number I can divide all those numbers by evenly?
You can divide them all by 2.
Okay. If I divide them by 2, that gives me C3H6O3. Can I divide C3H6O3 by one number?
No.
No?
Oh, yeah, 3.
Okay. So I divide it by 3 again. How many C's do I get? I first divided it by 2, then I divided it by 3 again. What's the C? Divide 6 by 2, you got 3. Divide the 3 by 3, how many C's do you have?
A lot.
Divide 6 by 2.
6 by 2 is 3.
Divide 3 by 3.
1.
So you have 1 C. Okay.
Yeah.
Divide H. You divide the 12 of H's by 2. You get how many?
6.
Divide the 6 by 2. Divide by 3.
Divide the 6 by 3 is 2.
Do you need a calculator? Do you need a calculator? I'll wait for you to get a calculator.
No, it's just like I have a problem taking things in like verbally.
Yo, honestly,
so like
I
just have to
I get super nervous when people ask me math questions to the point where like someone can ask me what's like 2 plus 1 and I'll be like,
That's why all right. This is not supposed to be pressure oriented, Aaron. Okay. If I've been pressurizing you. All right. Divide 12 by 2, you get
6.
Okay. Divide 6 by 3, you get
2.
2. So you got so far C1, H2. Divide 6 by 2.
3.
Divide 3 by 3.
1.
So my overall empirical formula for this would be CH2O. We good with this?
Yes.
Does this make sense? Is there anybody confused about the difference between molecular and empirical formulas?
Wouldn't it have been easier to just divide it by everything by 6?
You could have done that. You could have done that, but Aaron wanted to make me suffer.
wait, when you say divide everything by 6, you're talking about divide 6 plus 12 plus 6 by 6?
No. Divide 6 by 6, you get 1.
Okay.
Divide 12 by 6, you get 2. Divide 6 by 6, you get 1 again.
Okay.
Yes.
So basically you're taking like the common denominator among the numbers and you're just breaking it down to the got it. Okay, that's easy.
That's all you're doing.
Simplifying it.
That's
Big
all
brain.
you're doing.
Got it.
You're just simplifying the formula down. That's all.
Professor, I have a question.
Rosina.
We just barely figured out how to write the molecular formula. And now why do we need the empirical? So,
Ooh, why do we need it? Oh, because it's going to become very, very important. Because sometimes when you do analysis, what you end up doing is being able to determine the molar ratio between the atoms. And the ratio of the atoms, 1 to 2 to 1, is the same as the ratio 6 to 12 to 6. Okay? And when you make that determination, you're making an empirical formula determination. You have to have additional information to get the molecular formula.
okay, thank you.
Okay. Now we're getting into actual nomenclature. All right. Slideshow from current slide. Why are you? Yes, there we go. We're going to learn how to name these guys. We're going to learn how to go from the name to writing the chemical formula, and we're going to go from writing the formula to the name. And it's going to be easy. It's going to be a piece of cake, guys.
Is it though?
It's a piece of cake. I'm gonna take you through a simple pattern, okay? I'm gonna lead you down a path, Terry. Okay, just think of me as the wolf and you are Little Red Riding Hood. You have nothing to worry about, Terry.
All right. Whatever you say.
I'm as comforting as a scream in the night, I know. So we're gonna have three basic types of compounds. We're gonna name ionic compounds, we're gonna name molecular or covalent, and we're gonna name acids, okay? Now, when we do this, okay, we are going to ask ourselves a series of questions. Ionic compounds can be broken down into two types, so can acids, and so can covalents, okay? They all can be broken down into two different types. So if I have a chemical compound, first question I am going to ask.
I feel warm too.
I feel bad. Baba.
We going tonight?
First question I'm going to ask.
Oh, I'm so sorry. I'm so sorry. I'm so sorry.
First question I'm going to ask. I'm going to look at my compound. I'm going to look at my first element and I'm going to say, is there a metal? If it's no, I'm going to use covalent rules. If it is yes, okay, I'm going to ask myself a second question. Is the metal a type 1 or a type 2? Remember, I said cations can be type 1, I know the charge, or type 2, I got to figure out what the charge is. Okay, so if I have a type 1 metal that I know the charge, guys, I am lazy. How many times have I told you that? All right, if I know what the charge is, why am I going to bother writing extra stuff down about it? Okay, type 1, I just use the element name. That's all I have to do. If I don't know the charge though, then what I have to do is I have to determine the charge, then name the charge with a parentheses, Roman numeral inside the parentheses. So to review this, I'm going to look at my compound. First thing I'm going to ask myself, is there a metal? Is the first element a metal? If it is, I use ionic rules. If the first element is not a metal, I use covalent rules. If the answer was yes, I have a metal. Second question I ask, is it a type 1 or a type 2? If it's a type 1, I do not need a Roman numeral. If it is a type 2, I need to find out the charge and put the charge in parentheses as a Roman numeral. Are we fair and good here, guys? Fair and good? Rosina?
No, it's really confusing. I guess
gonna
we
look.
need to practice, perhaps as we practice, we'll
Amazing.
get to
Isn't
know.
it enough? Look,
In the words of Gabe, can I get an example, sir?
guess what? Look at this. Look at this. Look at this. You want practice? I'll give you practice.
I was
3
gonna say-
pages, 4 pages, 5 pages. Oh my God, look at this. 6 pages, 7. We have, you wanted, just because Rosina asked for it, I gave you practice.
They could have banned me from this class.
The survivor guide actually gives really good like steps on how to name the ions. I was looking at it and I was showing you like how to name like a sodium chloride. It gives you 3 steps: name the metal, then the anion, and then combine it.
That's where I'm going. That's exactly where I'm going. Okay. So we're going to look, we're going to see that the first element is a metal. We're going to determine whether it's a type 1 or type 2. And remember, type 1s, first column, second column, silver, zinc, aluminum, cadmium. Those are all your type 1 metals. If it's not one of those, it's a type 2. And you have to include a Roman numeral. Okay, so the bottom line for this, ionic compounds are when the electronegativity is greater than 2. We're talking about metals and non-metals here. So the first element has to be a metal. We have 2 different parts to this. Cation always comes first. The metal name will always come first. Anion comes second. Again, we have 2 different types of cations. Charge is known. First column, always a +1. Second column, always a +2. Silver, zinc, silver is a +1 always. Zinc is a +2. Aluminum +3. Cadmium +2. Bismuth, if you want to remember, it's a +3. If it's not in one of those categories, it's a type 2. And you need a Roman numeral. Terry, silver. Terry, is
Yep.
silver one of my type 1 elements?
I have to get back to you on that one. I can't.
Silver is a metal.
Terry, did I just say silver is always a +1?
You did just say that. You did. You did.
Okay, so type 1s, I do not have to use a Roman numeral. So if I have silver chloride, I just call it silver. Cadmium, another one of the ones, another one of the special ones. Cadmium is always a +2. I just call that cation cadmium. Magnesium is in column 2. It's always a +2. I just have to call that magnesium.
Well, then how do they distinguish between those and just straight up the element, like later on? Like if you isolate an element and you're working with both, then how do you distinguish that?
I'm not understanding the question, Hunter.
Like if you go back, you said it was silver, silver chloride. If it's just called silver, then like later on, like let's say you're working.
I'm just naming the cations right now, Hunter. That's not the full name of the compound.
Oh.
That's only half of the name. That's only the cation half.
Okay, I thought you meant to refer to it as.
No.
Okay.
That's only the cation half of it. Okay. Let me see who's out there yet. These are all type 1. Katie. Katie.
Yeah.
All right. These are all type 1. Do I need a Roman numeral, Katie?
No.
No, I don't. Okay.
All right, good.
Name the cation.
Jesus.
Top one.
Sodium.
Sodium, good. Okay, we're gonna go with, Gate. Gate, you out there, Gate?
Present.
Okay, Gate. What's the cation for BaCl2? Name the cation.
You know, Professor, I'm gonna go ahead and be straight honest with you. This 2021, I'm confused as hell. I'm beyond confused. So I'm like I'm gonna rewatch this lecture because I mean I'm like I
Okay,
don't know if I'm
all right, no problem, Kate. No problem. Jennifer, BaCl2.
Yes. So Ba is barium.
Okay. Do I need a Roman numeral?
No.
It's a type 1. I don't need a Roman numeral. Okay, we're gonna go with Neela. Neela, you there?
Yeah, I'm here.
AgNO3.
Silver.
Silver. Okay, guys, these are all type 1. I do not have to add a Roman numeral because I all know if it's silver, it's a +1 charge. If it's barium, it's a +2 charge. Fair enough? If I have a type 1 cation, I already know the charge. I don't need to add a Roman numeral. Now, if I have a type 2, I got to name the metal followed by the charge that's written in Roman numerals, in parentheses. I look at CuO. Okay, CuO. Oxygen -2, there's one of them. Therefore, the charge on my copper is a +2. Copper 2 oxide. I'm looking at my iron nitrogen compound here. Okay, Hunter, you like to use the cross thing, right?
Yeah.
What's the charge on my iron?
On your iron, it's 2.
So I call it iron parentheses Roman numeral 2.
2. Okay.
Okay. Andrew, other Andrew. Okay. Lewis.
Yes, sir.
Okay, Lewis. My blast. Okay, Lewis. My sulfur has a -2 charge. How many sulfurs do I have? What's the subscript on the sulfur, Lewis?
2.
So 2 times the -2, what's the total negative charge?
-4.
All right, that -4 balances with,
Wait, where'd you get the -2?
because sulfur has a -2 charge.
Okay.
Okay, Lewis?
Okay.
So the -4 balances with how many positives?
4.
4. Okay, so how many cobalts is that +4 distributed amongst? What's the subscript on the cobalt?
1.
So I divide the +4 by 1. What's the charge on that 1 cobalt? 4 divided by 1, Lewis.
4.
4. So I call COS2 cobalt 4 sulfide.
Okay.
I have SnCl2. Mariah, you out there, Mariah?
Yeah.
Okay, Mariah. Can you determine what the charge on SnCl2 is? What's the charge on the SN?
It is 2 positive.
2 positive. So name the cation.
10 chloride.
There we go. 10 Roman numerals 2 chloride. Perfect. Absolutely perfect. See somebody who I haven't talked to. Well, Curtis. Curtis, you out there?
Yes, sir.
Okay, Curtis. PO4 is a -3. The reason I'm telling you that is because I'm sure you guys don't have them memorized yet. If PO4 is a -3, can you tell me, Curtis, what's the charge on the AU?
Will it be a +3?
So what is the name of this cation?
Silver
Nope,
Roman
no,
numeral
no,
3.
no. Gold.
Oh, gold. Gold Roman numeral 3.
Gold Roman numerals. Guys, if you're having trouble between gold and silver, remember the Goldfinger movie. Goldfinger's first name was Auric, Auric. Okay. So hopefully maybe that'll help you determine the two. Now, why do we need to know this? Why do we need to put that Roman numeral in there? That's because if I go and tell you, go bring me some copper sulfide. When you're looking on the shelf, you're not sure that I asked for Cu2S or Cus. You don't know which one if I just say copper sulfide. So I have to define which one it is. Cu2S is copper 1 sulfide. Cus is copper 2 sulfide. And I think we're going to leave it there at the moment. But we got to go through. And we got to go through and do the attendance real quick. Yes. What am I doing? Where are you? Yeah, that's where you are. Okay. Gaith is here. Davila. Monica, oh, sorry, wrong one. Omar's here. Lewis is here. Christina was here. Gaith is here. Zaina.
She said in the beginning of class that her mic wasn't working. I don't know if she's still here.
Curtis is there. Terry's been here. Apple Grace.
I'm here.
Hunter is here. Marie's here. Jadania, rather. Chase is here. Fabiana, I've seen. Leandre.
Here.
Armith is here. Nyla's here. Kaylin answered a question. Aya.
Here.
Elizabeth. Kevin.
Kevin also said his mic wasn't working at the beginning of class.
Shemaya.
Here. Shamira here.
Sorry, Shamira.
It's okay.
Mariah's here. Aaron answered a question. Rosina. Andrew Melick. Katie was here. Cash.
Here.
Hayden, I saw. Faith was here. Mila was here. Jennifer was here. Alec. Going once.
I'm here. Sorry about that.
Brian.
Here.
Helen, I think I saw. Spencer.
Here.
Tori.
You mean Victoria or Tori?
Okay, I'm sorry. I thought you told me to call you Tori.
Nope.
Victoria.
I am here.
All right. Okay.
Professor,
Guys, yeah.
my mic wasn't working when you asked me the question, but I do know the answer. I just want to put that out there.
Okay, who's this?
Gaith.
Okay, Keith. All right. Now, yes, guys, I know this is overwhelming. I do know that. But we're going to keep on pounding away at it, okay? Right now, we are through with going and identifying the first half of the ionic compounds. If the first element is a metal, you're using ionic rules, okay? Ionic rules mean you name the metal first. You look at that metal and you determine whether it's a type 1 or type 2. Type 1, column 1, column 2, or silver, zinc, aluminum, cadmium. If it's any of those, it's a type 1, does not need a Roman numeral. If it's anything other than those, it's a type 2. You don't know what the charge is, so you got to determine the charge, put it in as a Roman numeral in parentheses. So that basically summarizes where we're at today. Okay? Questions before we go? I'm hearing crickets.
I don't think there's any questions.
Mila, could you stay afterwards?
Yes.
Okay. Any other questions, guys?
No, are they good?
Okay. So
See you in the lab.
bye-bye. I will see you. We're going to pound at this. We're going to keep on going after it, okay?
Yep. See you
Alrighty.
later. Bye.
See you later.
Bye.
I might be seeing you guys in a half an hour.
Bye.
Bye. Bye. I need you all out of here. Fabiana, Zaina, Kate, Zaina. Zaina. Going once. Okay. All right. How are you doing?
Good. I knew I did really bad on the test.
Oh, that's obviously, I'm sorry. Some people have a way of joining in and not, I'll say one other thing I'm going to do.
The honor lock.
Just
Honestly,
one second, Mila, okay?
Okay.
No, I don't want to stop video. Crap. I'm trying to get it to stop taping is what I'm trying to get.